Section 1.1, Linear, Rational, and Absolute Value Equations. At the beginning of some sections, I will have some mathematical concepts that you should be familiar with that I will just quickly go over. For section 1.1, I will talk briefly about the properties of equality. If A and B are algebraic expressions and C is a real number, then the following equations are equivalent to A equals B. What that means is, for example, number 1, we know that 6 is equal to 6. So there's our A and B set equal. If I add the same number to both sides, and we know that 6 plus 2 is 8, then I have an equivalent equation. For our second example, the subtraction property of equality, if I have two numbers set equal and I subtract the same number from them, well, then I obviously get another equation that is true. The multiplication property of equality, C cannot be 0 because if we multiply anything by 0, it goes away. It becomes 0. So that is irrelevant. But for example, 3, 6 equals 6. And if I multiply 6 by 2, and I multiply this 6 by 2, then I get 12 is equal to 12, another true equation. Number 4. I cannot, for the division property of equality, I cannot divide by 0, so C cannot equal 0. So if I have 6, my pen doesn't want to work, 6 equal to 6, and I divide both sides by 2, then I get 3 is equal to 3, which again is a equivalent equation. They are all true statements. Let's move on to the distributive property. If I have a number A times the quantity of B plus C, well, that's equal to the sum of A times B plus A times C. Here's an example of that. 6 times the quantity 2 plus 3. I'm saying that's equal to, well, in this case, A is 6, so that would be 6 times 2 plus 6 times 3. Well, we know that 2 plus 3 is 5, so on the left side we have 6 times 5. And on this side we have, well, 6 times 2 is 12, plus 6 times 3 is 18. Well, 6 times 5 on the left side we know equals 30. And 12 plus 18, well, that also equals 30. So again, we see that the distributive property is true. The least common denominator, that is something that will be really useful in several instances, and so I want to define it. The least common denominator, or LCD, is the lowest common multiple of a set of fractions and makes adding and subtracting fractions simpler. If my fractions that we have are 1/2, 1/3, and 1/4, I can't add 1/2 to 1/3 without changing the denominator. So what we do is we look for the multiples of our denominators. In this case, we have 2, 3, and 4. Counting up by twos, 2, 4, 6, 8, 10, 12. Counting up by threes, I have 3, 6, 9, 12, 15, 18. And by fours, I get 4, 8, 12, 16, 20, 24. We can see that the least common denominator, or LCD, for these three fractions would be 12, because 12 is a common multiple of all of the denominators, and it is the smallest one. Moving on. Solving linear equations. A linear equation in one variable is an equation of the form ax plus b equals 0, where a and b are real numbers and a doesn't equal 0. We say a cannot equal 0 because a times x would then be 0, and we would just have b equals 0. An example of what this would look like, maybe, is 3x plus 5 equals 0. Another example that doesn't look like this form of a linear equation in one variable would be 2x minus 2 equals 7. It doesn't look the same, but if I use the subtraction property of equality and I subtract 7 from both sides, 7 minus 7 on the right gives us a 0, and the 2x is not affected by the minus 7, but negative 2 minus 7 gives us a negative 9. And so it can be rearranged to look exactly like the form ax plus b equals 0. Other linear equations might look like this. Or it might have to have some distribution going on. These are all examples of a linear equation in one variable. They have one variable, only x, and there is no power on the variable. Now, the values for the variable that make the equation true are called the solution set. To solve a linear equation is to identify the solution set. We are going to solve the following linear equations, and we are going to use those properties of equality that I spoke about a little while ago. 5x minus 6 equals 14. Well, the first step is to isolate the variable on one side. So if I add 6 to both sides, then what I get is 5x equals 20. And then, since 5 is being multiplied by x, I will use the division property of equality, and I will divide both sides by 5. 5 divided by 5 is 1, so I have 1x on the left, and 20 divided by 5 is 4 on the right. And so our solution set is a set of one number, 4. Always check your answer. By plugging 4 back in where the x is, well, what is 5 times 4? That is 20. And 20 minus 6 equals 14. So it checks out. Our next example will use the LCD, and it will illustrate how we are going to use that. The LCD for 3 and 4, because those are the denominators, would be 12. So if I multiply both sides of this equation by 12, then I still have a true equation. And 12 times 1/3 would be 4x minus 12 times 4 is 48. And then here, 12 times 3/4. Well, let's look at that real quick. 12 can be written as 12 over 1 times 3/4. We can do this two ways. Multiply straight across on the numerators, and we get 36 over 4, which simplified becomes 9 because 36 divided by 4 is 9. Or we can factor it out. How many 4s go into 4? 1. How many 4s go into 12? 3. Now multiply straight across. We get 9 over 1, which is just 9. So I get 9x minus, and 9 times 12. 9 times 12 is 108. So now I combine like term, or I use the addition and subtraction property of equality to get the x only on one side. I will subtract 4x from both sides. And then since I brought the x to the right side, I will add 108 to both sides. And the resulting equation will be 60 equals 5x. Because the negative 48 and the 108 give us 60, 4x minus 4x gives us 0. And then again, using the division property of equality, I will divide by 5, and I see that x equals 12. Always check your answer. I will not do it here for time's sake, but the solution set is the set that contains the number 12. I will continue with these examples in part 2.